This next lesson covers one of the most important properties in all of algebra, the distributive property. As we start our study of the distributive property, I want you to keep the root word here in mind, to distribute. And there's lots of different ways to approach teaching this. I'm going to try a couple of ways. I'm going to introduce it one way using some geometry, and then try to clarify it using the word distribute. And then we'll talk a little bit about what to do with different signs, like the positives and the negatives, and how that would work in distribution. So this is kind of a neat way to visualize it. Suppose I have two rectangles that are the same size. Just assume they're the same size. Okay, I'm freehanding it here. The area of a rectangle is the base of the rectangle times the height of the rectangle. Now, what I'm going to do with this is actually split it into two rectangles, not quite equal. And we're going to think of this problem in two different ways. So we're going to plug some numbers in. So if you're like, where is she getting these numbers? I'm making them up. So we're going to call the height of the rectangle, say 3, and we'll call this 4, and we'll call this 2. Okay. Now we can think of this two different ways. On the left, we are going to think of it as one rectangle. Okay, so just kind of hang with me here. That is one rectangle. So the height of the rectangle is 3. The base of the rectangle is 4 plus 2. Okay, so the base of it would be the 4 plus the 2. Now I know you're thinking, well, that's 6. Yes, I know it's 6, but for now, keep it as 4 plus 2. So if the area is the base times the height, then this would be 4 plus 2 times 3. So far, so good. Now, with the one on the right, though, now keep in mind these figures are exactly the same. We're going to think of it as two rectangles. We're going to think of it as, we'll say, the blue rectangle and the green rectangle. So for the blue rectangle, the area of the blue, we'll do it in blue, okay, would be the base times the height. So the base of the blue rectangle is 4 times the height of the blue rectangle is 3. And the area of the green rectangle, well, the base is 2 and the height is h, apparently, 3. Okay, so what we did there was we just broke it up into 2. So the base of the blue is 4, the height is 3, the base of the green is 2, and the height would be 3. And the area of the whole thing would be 4 times 3 plus 2 times 3. Now, this probably seems like a really weird exercise, and hopefully I didn't lose too many people in it. You kind of have to see where it's going. What we want to look at is these two formulas down at the bottom. That these are exactly, but they're equivalent, but they're written differently. And we can actually show, the reason I want to start this with numbers is because you can actually show that they're the same. Now, it's reasonable that they're the same. Okay, on this one, we added them first, 4 plus 2, and then multiplied by the height. On this one, we're multiplying by the height, we're finding the area of each separately, and then adding them together. Take a look at it. So here you've got like the 4 plus 2 inside the parentheses and the 3 multiplying on the outside. Here, the 3 is distributed to everything in the parentheses. So just to confirm that these are the same. Okay, just to confirm, we would use our order of operations. 4 plus 2 is 6, and 6 times 3 is 18. Over here, 4 times 3 is 12, 2 times 3 is 6, and 12 plus 6 is 18. So I like to start that one with numbers because we can verify that it actually doesn't matter which way you find the area. You can find the area of the whole thing, or you can find the area of each separately. Both of them are going to give you the correct answer. So how does that relate to algebra? Well, in algebra, we often have a variable. So let's go through the same exercise. We'll keep the height as 3. We'll keep this, well, let's make this our x, and we'll keep that as 2. So now we have an unknown, like our length or our base of our rectangle is not known. But the same should hold because math is consistent. And if it works with the numbers, it's going to work with the variables. So for the rectangle on the right, we have the area is equal to the base times the height. This time, the base is x plus 2. We actually can't add them together. We cannot simplify that. X plus 2. I don't know what x is, so it's just x plus 2 times the height, which is 3. Over here, okay, we have our blue rectangle, which is going to give us a base of x and a height of 3. And then we'll have our green rectangle, which is going to give us a base of 2 and a height of 3. And what we know about this area, the area of the whole thing, is that that is x times 3 plus 2 times 3. So what I'm going to do is write this as a single statement. If you have something in parentheses multiplied by a number or a variable multiplied by something, that is the same as if that number on the outside multiplied each thing inside individually, okay? So you could take everything in the parentheses and multiply it by something on the outside. That is the equivalent to taking the number on the outside and multiplying it by everything individually. So you'd go 3 times x, and then you have the plus sign, and then we'll do 3 times 2. Which would be over there. Now, this is a very awkward way of writing it. And if you're familiar with the distributive property, you're probably thinking that's a really awkward way of writing it. Usually it's written the other way around. Just when we're talking about bases and heights of rectangles, it's more comfortable to do them kind of horizontally. So normally the way we would write that is we'd put the 3 on the other side. We just change the order, okay? And here, instead of x times 3, we would write 3x. And then just to keep the order consistent, we would write 3 times 2. Now, this multiplication sign right here is not needed because the implied operation there would be multiplication. And that right there is basically a justification of your distributive property. So let's go right into the nuts and bolts of the distributive property. The distributive property looks like this. If you have some number or variable, okay, multiplying something in the parentheses, that is the same as if you took what was on the outside and multiplied it by each thing individually. So each term, so that could be a times b plus a times c. Now, it doesn't matter if A or B or C are positive or negative. Like, that's not going to change it at all. It also doesn't matter if you had more stuff. So if you had A plus B plus, or A times B plus C plus D, the distributive property would still hold. So that would be the same as if you multiplied each thing individually. Sometimes I like to think of it as this. The parentheses are grouping symbols. So the A is multiplying the group. The whole group is getting multiplied. Everybody in the group is getting multiplied. Now, a lot of times when teachers do this, they'll actually draw some like arrows and stuff. So let's say you had 3. We'll do the 3 times x plus 2. Okay, so they'll do this. They'll take like a different color or something, and they'll do this. They'll do 3 times x, and then they'll come over here and write 3x, and then they'll draw this like little arrow in there, and they'll say 3 times 2. And honestly, most of the time we will skip that because most of the time we can do 3 times 2 in our heads and we'll just say 6. We'll just go straight to the 6. Now, I see quite a few Algebra 2 students who actually they confuse the arrows with the actual distribution. The arrows are a visual tool that teachers will use to help students track their eyes over what we're doing, but the actual distribution is the multiplication. So, distribution is multiplication. It's just multiplication over a group. Okay, and it's very specifically defined as multiplication over addition or over subtraction. Now, here's where the word distribute comes into play. It's like the 3 is being distributed to everything in the parentheses. I used to explain it this way, like if the principal comes to my classroom and hands me a stack of notices and says, here, distribute these to your students. If I only give a worksheet to or notice to the first student, I haven't distributed them. When the principal tells me to distribute something, what he or she means is you need to hand one to everyone in your class. If you haven't handed it to everyone in class, you haven't done the distribution. Now, sometimes people will do subtraction as a separate thing with their distribution. So they'll actually have a separate rule for they'll put it in a little box like subtraction is different. But remember a couple lessons ago, subtraction is adding the opposite. So if you saw the subtraction, you can change it to addition, and then everything that you've learned is true for addition also works for subtraction. And so here we would distribute the 3 through. So 3 times x is 3x. 3 times negative 2 is negative 6. And you can write it as plus negative 6, or if you would prefer, you can write it as 3x minus 6. Okay? So that's pretty much what distribution is. We want to get good at handling it. There's a couple of things that happen with the signs when we get to more complex algebraic expressions. But for now, we just want to get good at doing distribution. Now, remember, most of the time when we look at distribution, we're distributing from the left. And that's partly because we're comfortable looking at things from left to right. But if you go back to that original example, that was kind of awkward to look at, we're actually distributing in from the right. And that works as well because multiplication is commutative. It's just kind of weird to look at when you're coming in from the other side there. So let's do a couple of examples. Let's say we have 2 and then we're multiplying that with the x plus 5. We'll do one of these awkward looking ones. We'll do x minus 4 and then we'll multiply that by x. Now, technically you don't need a multiplication symbol there. I just personally find it weird to look at, so I put one in there. I'll do the same thing right here, 1 plus 2x, and then you could just write 8, that would be the implied operation. I just don't like it. All right, let's do one with some negatives. That can cause some issues. And, let's do this one. All right. And we'll do one more. X plus y minus 5. Okay, so in doing this, this is what we call handling the content. Now that you've got the idea of what distribution is, you just have to practice doing it so that you become comfortable with it. So for this first one, I'll do the little weird arrows. Okay, just remember the arrows are not the distribution. The arrows are just to help you track your eyes over the problem. So 2 times x is 2x, and then you can write 2 times 5 like that, but most of us are going to just do that in our heads. We know what 2 times 5 is, and so we're going to go straight to the 10. For the next one, we're distributing in from the right. It's kind of weird, but it doesn't change anything. Math is consistent. So x times x, that would be x to the second power. And then if you want to, you can you can rewrite that as plus negative so that you can see what you're multiplying. And we're multiplying x by negative 4. So x times negative 4 is negative 4x. You can write it that way, or you can write minus 4x because that's all plus negative is subtraction. It's really, really helpful to remember that when you're looking at subtraction, you are looking at a negative there. This is a negative 4x. It's not minus a positive. It is minus a positive, but It's a negative 4x. Now, for this next one, I'm not going to do the arrows. I'll kind of track them with the little pointer thing. Okay, so we're going to do 8 times 1. Well, 8 times 1 is 8. And then 8 times 2x. So we'll do a little bit of scratch work. 8 times 2x. Well, remember that's 8 times 2, which would give you 16. And then it'll be 16x. So that'll be 16x. That's from a previous lesson where you would multiply the two numbers. So, because it's just multiplication straight through. The next one, negative 3 times x is negative 3x. And then we have the plus sign, and then negative 3 times 4 is negative 12. And then you might look at that and say, ooh, I don't like plus negative. And so you might say, well, that's negative 3x minus 12 instead. For me personally, like my Algebra 1 teacher made me write it like that. My mom thought it was silly that I had to write it like that. Most people will write it this way. Neither one is more right or more wrong. What's important is that you're writing it in a way that makes sense to you and you'll reliably get the problems correct. That's what the important thing is. Okay, I thought this next one was interesting. We have a positive 6 and then we have like a negative 3x, okay? So we have like a positive and a negative. And we're going to multiply it by a negative 1. So when I go to multiply that through, I have negative 1 times 6, which is negative 6. And now I've got negative 1. Now let's like make sure we look at this right. This is plus negative, okay? So when you're distributing this, it's negative 1 times negative 3x. Negative 1 times negative 3x. That minus sign means the 3x is negative. So negative 1 times negative 3x. A negative times a negative, we learned in our last lesson, is positive. And what is interesting to note about that is multiplying by negative 1 flipped the sign. So the positive 6 became a negative 6. The negative 3x became a positive 3x. Kind of file that away under stuff that you know. Last one, 2 times x is 2x. 2 times y is 2y, and then you can either bring the minus over or you can say that's plus negative and then say that 2 times negative 5 is negative 10, and then you're welcome to change that back to a minus sign. Do what's going to work for you. So that's our lesson on distribution, and as always, I'm going to put some practice problems on the next slide so that you get a chance to reinforce the material. All right, here we go. 3 times y plus 6, x plus 1 times 11, negative 4 times y minus 2, 4 times 10 minus 3x, 4x times x minus 20, negative 4a times 3a minus 4, and then the last two are to simplify. Negative 3 times x plus 1, and then minus 2, and then a really tricky one there, x squared minus, and then after the minus sign is in the parentheses, 4 plus x squared. So pause the video, try to work these out, and then we'll go over them together. Okay, I put the first 4 on the same page together because these are what I would call garden variety. We just want to practice the concept. And so for this first one, we have 3 times y plus 6. So we're going to distribute that multiplication through the parentheses. 3 times y is 3y, and 3 times 6 is 18. And feel free to just multiply that. Just don't lose sight of the fact that what it is 3 times y plus 3 times 6, because this little fact it becomes really handy later in algebra when we start factoring. It's when we have to go backwards. So kind of hang on to that. For the second one, we have x plus 1 times 11, and in this one we're doing that distribution from the right, which looks a little weird, but it's the same deal. 11 times x and then 11 times 1, so that would be 11x plus 11. The third one, we have negative 4 times y minus 2. And if you need to, just remember that is y plus negative, that you are multiplying by a negative there. Negative 4 times y is negative 4y. And then negative 4 times negative 2. Negative 4 times negative 2 is positive 8. And then the last one in this batch is number 4. So we have 4 times 10 minus 3x. And we go ahead and distribute that through. 4 times 10 is 40. And then this is 4 times negative 3x. And anybody who's done this for a long time, we don't even think about it. We're like, yeah, that's 4 times negative 3x. When you're first doing it, though, you might need that reminder. It's plus negative 3x to remind yourself that the 30 is negative. So 4 times negative 3 is negative 12, and then the x is there. And then, of course, you can write that as a minus. I'm obviously comfortable with the minus sign. That's how I do it. But I also see what a lot of my students do, and I know that it often benefits students from thinking of it as a plus negative. And of course, I did that when I was a student myself. So, and I turned out okay. All right, for number 5, all right, we're going to distribute the 4x. So that's going to be 4x times x. Now just remember, this is just 4 times x, and we know that x times x is x to the second power. So that's going to be 4x to the second power. Remember, this right here is plus a negative. So you have 4 times x times negative 20. The commutative property allows you to switch the order. So instead of doing x times negative 20, you could do negative 20 times x. And what that does is it puts the two numbers together. So 4 times negative 20 is negative 80. And then you'll have the x. And then you can say 4x squared minus 80x. On the last one here, or last one on this page, we have negative 4a times 3a. So that's negative 4 times a times 3 times a. And what I'm going to do is use the commutative property to switch those two around. Negative 2 times 3 times a times a. Negative 4 times 3 is negative 12, and a times a is a to the second power. Then here, remember that's plus negative, so we're going to have negative 4a times negative 4. Well, a negative times a negative is going to give me a positive, and then we'll have 4 times 4 is 16, and then we have the a there. Now, this stuff that I did here, okay, this is scratch work. And for most of your math teachers and stuff, we do that in our heads. We don't even think about it. It's become very automatic. What I'm doing there is I'm doing it out for you so that you're able to kind of see the reasoning behind it, and you're not just trying to make connections that may or may not be made right. All right, for these last two, we need to simplify. So for this first one, we have negative 3 times x plus 1, and then we have minus 2. So when I go to distribute, negative 3 times x is negative 3x, negative 3 times 1 is negative 3, and then I'm going to take this and change this over to plus negative 2 just so that we're uniform. Now when it says simplify, it means we want to get this as simple as possible, and I can't do anything with the negative 3x, but I can do negative 3 plus negative 2, and of course on our number line that would mean going left to 3 and then left 2 more, and we'd end up going left 5. And you can leave that as negative 3x plus negative 5 or negative 3x minus 5, either one. For the last one, I wish I had more time. Okay, for this last one, this is tricky, okay? Notice that the subtraction is subtracting the group. Just like earlier in the lesson, like the 3 is multiplying the group, the whole group. So if you are subtracting the group, it means you have to subtract everything in the group. So literally what we end up doing is we end up distributing the negative. Some people will think of it this way, okay? They'll think of it as plus a little -1. I'll let you think about that for a second, okay? Plus a little -1, because multiplying by 1 doesn't do anything. It doesn't change anything to multiply by 1, and then you kind of sneak that negative in there for the subtraction. So this would be x squared, and then -1 times 4 is -4. -1 times x squared would be -1x squared. Now remember that this is a 1 right out in front here. And so if you have 1x squared and -1x squared, those are what we call opposites. And we know that opposites cancel each other out. Picture that number line, okay? Here's the 0. I don't know where x squared is, but I know that -x squared balances it out and they'll add up to 0. And so these are going to end up canceling each other out, leaving me with a -4. So that one was a real slick one. Sorry this video ran a little bit long, but distribution is that important. I promise the next one will be shorter.